Hi students, now I am going to teach 10th standard physics lesson number 1, Newton's universal law of gravitation. So see the figure A, B, two bodies. Mass of the A body is m1, mass of the B body m2. The two bodies are separated by distance r. m1, m2, mass of the two bodies, r distance between the two bodies. So what it told statement, every particle of matter, so matter means you know very well, exists in solid state, liquid state, gaseous state. This is called matter. Every particle of matter in this universe attract every other particle with a force. This force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The direction of force acting along line joining the masses. Force is proportional to product of masses, that is m1 into m2. Force is inversely proportional to 1 by r square. So combine these two forces, we obtained F is proportional to m1 m2 by r square. So finally F is equal to g m1 m2 by r square. So F equal to g m1 m2 by r square. Here g is a universal gravitational constant. The value and unit of g is 6.674 into 10 to the power of minus 11 Newton meter square kilogram or minus 2. So in this equation, F is directly proportional to product of the two masses m1 m2, but inversely proportional to square of the distance. So force is directly proportional to product of the two masses. So mass increases, force increases. Mass of the body decreases, force also decreases. This is directly proportional. Then second, force is inversely proportional to square of the distance. Distance increases, force is decreases. A distance decreases, force is increases. So in universe, for example, in between the planets to planet, the gravitational force very weak because the mass of the two planets is very high, but force high, but the distance between the two planets is very greater than the mass. So the distance square increases, the force decreases. So gravitational force is a very weak force. So from this equation, gravitational force very weakest force is only attractive because every object thrown upward vertically surface of the earth, it comes down towards the earth. It's never move upward. So everybody attract towards the earth due to gravitational force. So gravitational force is only attractive force, is not repulsive force. So force is represent gravitational force. F is represent gravitational force. The gravitational force only attractive force, not repulsive force. Then another important point, the gravitational force does not depend on the medium where they are placed. Suppose the two bodies are in water. So gravitational force never change. Or the two bodies are in universe. In between the two bodies, air is present. Air act as a medium. The gravitational force is never change. So the gravitational force is constant. The body kept in water and then other medium also. So gravitational force does not depend on the medium where they are placed. The gravitational force only attractive, is not repulsive force. The next topic is acceleration due to gravity. Small g, g represent acceleration due to, but here the capital G represent gravitational constant. So acceleration due to gravity. So already we studied acceleration. Rate of change of velocity is called acceleration. That is acceleration A equal to change in velocity by time taken, or body velocity changes with respect to time is called acceleration. So here a body thrown up vertically upward from the surface of the earth, it reaches certain height and comes down towards the earth. Why the body comes down towards the earth? Because gravitational force is only attractive force. The gravitational force pulls the body towards the earth, so that the body comes vertically downward. So the body coming vertically downward, the velocity of the body changes. Here the velocity of the body changes due to the gravitational force. So acceleration produced on the body. So this acceleration is called acceleration due to gravity. So acceleration due to gravity means acceleration produced due to force of gravity. This is called acceleration due to gravity. For example, a coconut falling down towards the earth. So the coconut falling down due to gravitational force. While coming down, the velocity of the coconut changes. So acceleration is produced. So this is called acceleration due to gravity. Not only coconut, any object while coming down, the body comes due to gravitational force. Due to gravitational force, the body velocity changes. So acceleration produced. So acceleration produced due to force of gravity is called acceleration due to gravity. The common value, mean value of acceleration due to gravity, g equal to 9.8 meter per second square. Then the g value is not the same at all points on the earth, is varied. Equator, poles, altitude, latitude. Next, suppose they are asking like that, differentiate between small g and a capital G. So the capital G represent gravitational constant or universal gravitational constant. The small g represent acceleration due to gravity. This is the first point. Then the gravitational constant, its value 6.674 in 10 to the power of minus 11 Newton meter square kilogram per minus 2. Here the acceleration to gravity value 9.8 meter per second square. This is constant in all the places, but this is not a constant. It differs from place to place. This is the gravitational constant and acceleration due to gravity differentiation.